Welcome to part 2 of the explanation of conservation of energy. Here is a website that I found. You are absolutely able to Google this and play with this yourself if you want. I'm not going to require it. I'll even put the link in the assignment. You can go and play on this assignment on this website. Sorry, this is my dogs. And this will help you understand how potential and kinetic energy relate. So what we have here is a skateboarder. And what I'm going to do is he's pretty high up. So if you look at this bar graph right over here that I'm moving, you can see that the blue bar is pretty full. He's got all potential energy. And because he only has potential energy, his potential, the kinetic energy is at 0. And the total energy equals the potential. So if I start this simulation, look what happens. As he goes down the hill, he gets faster. And as he gets faster, let's pause it. And as he gets faster, now he's near almost to the bottom. He has almost all kinetic energy and very little potential energy. But as he goes back and forth, what's happening to the total energy bar? The yellow total energy bar is not changing. But all that's happening is that the kinetic and the potential are transferring back and forth between each other. At any given point, if you could just mentally pick up the green bar and place it on top of the blue bar, it would be the same height as the yellow bar. At any given point, if I stop, the green plus blue equals yellow. Green, blue, yellow. Green, blue, yellow. Green, blue, yellow. When I add them up, that's what it equals. Now, couple of things. Right now, we're on planet Earth. That's what it says right here. We're on planet Earth. But what if we went to Jupiter? What would change on planet Jupiter? Well, the only thing that would change on Jupiter would be the gravity. So with more gravity, you'd have more potential energy, but the same concept would work. All right, let's pause it. What if you went to the moon? Clear. If you're on the moon, you have less gravity. So the transfer still happens, but you just have less. Oh dear, there he goes. Well, the transfer still happens, but you just have less total energy that you're working with. And if you were truly in outer space, there is no gravity, so you have no potential energy. And according to Newton, you would just move in a straight line forever. Bye-bye. Okay, so let's go back to what we actually care about. What I'm trying to show you is that at any given point in time, the potential and the kinetic energy, they just go back and forth between each other and they equal the total. Now, you're probably wondering, wait, Zito, in real life, this person wouldn't go forever. And that's true. It wouldn't. And the reason he wouldn't is because friction exists. So I'm going to put a little bit of friction into this. And this is actually what happens in real life. There is a third bar of energy occurring. Now, just so you know, if I stop it, if I add all 3 bars up, they still equal the total. The red bar is called thermal energy. If you saw my other slide, thermal energy is heat, friction. When you rub your hands together, you create heat. As the skateboard rubs on the ground, it creates heat. So some of its energy is transferring to friction. And as more and more of the energy transfers to friction, you have less for potential and kinetic. And that's why you will eventually stop. So what this is just a simulation of how energy transfers occur. That's the real world. For purposes of our class, we're not going to talk about friction. We're just going to talk about how potential and kinetic energy transfer back and forth to between each other. Check out this website. There's so much more. You can make track. Check this out. Hold on. Oh yeah. Well, he's gone. He's going to come back. Don't worry about that. Okay. Yeah, check this out. Yeah. This is what I do in my life. Come on, get your life. Check this out. Yeah. Oh yeah, he fell. But nevertheless, so your assignment is going to be on Google or Physics Classroom, and you're going to get some trophies based off the concepts. No math, just concepts this week. Don't be afraid to ask for help.